Hello class 9, let's solve exercise 7.2 from your Ncert book. Question number 1 states that in an isosceles triangle ABC with AB equals to AC, the bisectors of angle B and angle C intersect each other at O. So what we can see here is triangle ABC, and here AB is equals to AC. The bisector of angle B and angle C intersect each other at O. So if we take the bisector of angle B, so BO is the bisector of angle B and CO is the bisector of angle C. Now, when they are extended, they meet at point O. Let us join A to O. So if we join point A with O, we will get this structure. We have to show that OB is equal to OC. So we have to prove that OB is equals to OC. So in triangle ABC, as we can already see that AB is equals to AC as given. According to the theorem that we have learned, their opposite angles should be equal. Therefore, opposite to AB is angle C or angle ACB, and opposite to AC is angle ABC. So they will be equal. If two angles are equal, definitely the half of those angles will also be equal. So I'm multiplying half in both the sides. Half of angle ABC is equal to angle OBC, because if we divide this particular angle, then we will get these two equal angles, because BO is a bisector. So both the angles are equal. So half of angle B or half of angle ABC is equal to ABO as well as angle OBC. For this particular proof, we are choosing angle OBC. So half of ABC is equals to angle OBC, and half of ACB similarly would be angle AOCB. So we are getting angle OBC is equals to angle OCB. Now we have another theorem that if two angles are equal, then their opposite sides of the triangle are also equal. Therefore, since in triangle OBC, angle OBC is equals to angle OCB, therefore we can say their opposite sides are also equal. Focus on triangle OBC. Therefore, we can say that OB is equal to OC. Hence, we have proved that OB is equals to OC. The second part has asked to prove that AO bisects angle A. So we have to prove this straight line is bisecting angle A, that is angle BAC. In triangle ABO and ACO, that is ABO, that is this triangle here, and ACO is this triangle here, we will prove that these two are congruent to each other. Why are we choosing these two triangles? Because the side AO is common to both the triangles. So if we can prove that these two triangles are congruent, then clearly we can use the corresponding parts of congruent triangles situation, and we can prove that AO is actually bisecting this angle A. Now, to prove them to be congruent, we already have AB equals to AC. We also have the condition BO equals to CO. We have just proved in the previous part of the sum. Next, we already know that angle B is equal to angle C by this condition. Since angle B is equals to angle C, therefore half of angle B is also equals to half of angle C. Now half of angle B is equal to angle ABO and angle OBC. But in this case, we are talking about triangle ABO. So therefore, we will choose this particular angle and not this one. So half of angle B in this case would be angle ABO. Again, for the other triangle ACO, half of angle C is equals to angle AOC or ACO. that is this angle. So these two angles are also equal by this condition. So what we can see here is this side is equal to this side, BO is equal to CO, as well as these two angles, this angle is equal to this angle. So we are getting the condition side, angle, side, SAS rule. Therefore, by SAS congruence rule, we can write triangle ABO is equal to triangle or congruent to triangle ACO. Please make sure you write the names properly. Since AB equals to AC, for the first two letters, we'll write down AB equals to AC. And the third side is obviously, or the third vertex is O, therefore we'll write down as O. So we'll get this condition OB equals to OC, so OB equals to OC. Hence, we can write down therefore by CBCT, as because these two are congruent to each other, therefore these two angles are also equal. Now if these two angles are equal, then they are divided by AO into equal parts. That is, angle BAC has been divided by the line AO into two equal parts, as we have got this condition. Hence, we can say that AO is a bisector of angle A. Question number 2. In triangle ABC, AD is a perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB equals to AC. So here we can clearly see that in this triangle ABC, AD is the perpendicular bisector, as a result of which angle D will be 90 degree and BD will be equal to CD, as AD is the bisector. Now, in triangle ABD and ACD, we have, so in this triangle ABD and ACD, these two triangles, we have AD as the common side. Angle ADB is equals to angle ABC, as both of them are 90 degree, and BD is equals to CD, as we have already proved here. Therefore, we can say by side, angle, side, SAS congruence rule, triangle ABD is congruent to triangle ACD. Okay. Therefore, we can say by CBCT, the side AB will be equal to AC, because AB, the first two, will be equals to the side AC. That is the first two letters of the name of the triangle. Therefore, we can say AB equals to AC by CBCT. Thus, if this triangle ABC has two sides equal, therefore it will be an isosceles triangle. Question number 3. ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB respectively. Show that these altitudes are equal. So we can see we have a triangle ABC, and here it is told that the sides AB and AC are equal. That means AB here and AC here are equal in length. It's also told that the altitudes are perpendicular, BE and CF are drawn to AC and AB. That means BE is a perpendicular on AC and CF is a perpendicular on AB. That means angle E or angle BEC is 90 degree and angle F or angle CFB is 90 degree here. So since ABC is an isosceles triangle, therefore by the given condition AB equals to AC. So by theorem that angles opposite to equal sides of a triangle are equal, we can say that since AB is equals to AC, therefore their opposite angles, here angle B is equal to angle C, or we can rather write angle ABC is equal to angle ACB. Since we will be focusing on the triangle AB, FBC and ECB, therefore we have written the same angles in terms of this triangle. Therefore, we can also write, since these two angles are equal, we can write FBC is equal to ECB. That's what we have done. Now in triangle BEC and CFB, we can see this is CFB and this is BEC. So we can see that this angle is equal to this. FBC is equals to ECB because we have just proved it right here. Then angle BFC and CEB are also equal because they are 90 degree, and side BC is common to the two triangles. So the triangle here is having BC and the triangle here is also having the side BC. So what we can see here is there are two angles and any other side which is equal. Therefore, we can say that the two triangles are congruent using the AAS congruency rule. As a result, we can see from the name that BE is equal to CF by CPCT. So we can say that BE is equal to CF. Now the question may arise why we have chosen these two triangles, because BE and CF are both in these two triangles. Therefore, we have to choose the triangles accordingly. Question number 4. ABC is a triangle in which altitudes BE and CF to sides AC and AB are equal. So by condition we can see triangle ABC has two altitudes BE and CF in it, BE and CF, which are equal in length, and also their altitudes to AC and AB. That means they are perpendiculars on AC and AB. As a result, not only BE is equal to CF, but BEC is equal to 90 degree and CFB is also 90 degree. With the given conditions, we have to show that triangle ABE is congruent to triangle ACF. So this is triangle ABE and this is triangle AFC or ACF. So we have to prove this triangle is congruent to this. So from the figure only we can see that angle A is common to both the triangles. And if we focus on only this triangle, then we can see here we have 90 degree at angle E. And if we focus on triangle ACF, then we can see right over here angle AFC is 90 degree. So we are getting already two angles are equal, angle A and the 90 degrees. Other than that, we also have the condition that BE is equal to CF for the two triangles. Therefore, we can say that we can apply AAS congruence rule. So, in the two triangles we have written the two angles are 90 degree as they are perpendicular, then angle A is common and BE is equals to CF as it is already given. Therefore, triangle ABE is congruent to triangle ACF. Then we have to prove that AB is equals to AC, that is ABC is an isosceles triangle. So to prove AB equals to AC, we can already see that in the triangle ABE and ACF, we have the sides AB and AC. Since we have already proven these two triangles are congruent, therefore we can settle a relationship between them, and therefore we can write, since triangle AB is congruent to ACF, therefore by CPCT AB equals to AC. From the name also we can see AB is equal to AC. Now since two sides of a triangle are equal, therefore we can say triangle ABC is an isosceles triangle. Question number 5. ABC and DBC are isosceles triangles on same base BC. So we can see that in the diagram, here is a common base BC for the triangle ABC and the triangle DBC. So here is a triangle and here is another one. So these two triangles have a common side BC. We have to prove that ABD is equal to ACD. D. So from the given condition, here we can see that in the diagram only it is given that AB is equals to AC and BD is equals to CD. Since it is given that AB equals to AC, therefore using the theorem for isosceles triangle, we can also say their opposite angles are also equal. Therefore in triangle ABC, if AB equals to AC, their opposite angles, this angle and this angle, are also equal by theorem. Again, for the other triangle BDC, we already can see in the diagram that BD is equals to CD. Since BD equals to CD, using the same theorem we can say their opposite angles here also are equal, that is angle DBC is equal to angle DCB. Now what we can see here is this angle is equal to this and this angle is equal to this. So if we add these two angles, we will get this complete angle ABD, and if we add these two, we will get ACD. So we have two equations 1 and 2 right over here depending on the equal angles of the two triangles. And if we add them, then we can see that the left hand side is coming as ABC plus CBD, that is equal to ACB plus angle BCD. So if we add them, if we add these two angles, we'll get angle ABD, and if we add these two, we get ACD. You can also substitute some values here. You may say that this angle is X, this angle is X, this angle is Y, and this is Y. So X plus Y here will be equals to X plus Y here. So since this angle is coming as X plus Y and this is also coming as X plus Y, therefore we can say these two angles are equal. You can choose any method to write it. Question number 6. Triangle ABC is an isosceles triangle in which AB equals to AC. So here we can see the diagram where we have a triangle ABC where the side AB is equal to AC. Now side BA is reduced to D such that AD equals to AB. Now we have to focus in this direction. That is, they have written the name of the side as BA. That means we have to start from B and move towards A and keep extending the line. We will stop at a point where we can see that the length of AB will be equal to length of this extended portion. So we'll mark that as D. And if we join, we'll get CD. So now this figure has the properties that AB is equals to AC and AB is equal to AD. So as a matter of fact, both of these sides are equal to the same thing. So we can say that AB will be equal to AC and that will be equal to AD as well. So we can write AB equals to AC as equation 1 and AB equals to AD as equation 2. If we equate these two, we will get the relation AC equals to AD. Now, in triangle ABC, we know that since this is a triangle, the sum of the angles will be 180. So, using the angle sum property, we'll write down angle ABC plus angle ACB plus angle BAC is equals to 180. Now, we already know the theorem that in a triangle, if two sides are equal, their opposite angles are also equal. So if AB equals to AC, therefore their opposite angles, that is ABC, will be equal to ACB. So here we have ABC is equals to ACB. So we'll replace ABC using ACB. So we can rewrite it as angle ACB plus angle ACB plus angle BAC is equals to 180, and that implies that twice of angle ACB plus angle BAC is equals to 180. We are adding 2 times of this. Mark it as equation 3. Similarly, in triangle ACD, we have the same angle sum property. We can take all the sides of this triangle ACD, that is angle ACD plus angle ADC plus angle CAD is equals to 180. So again we can see that AD equals to AC, therefore their opposite angles are also equal. So ADC is equals to ACD. So instead of ADC we can write down ACD. So twice of ACD plus CAD is equals to 180. Mark that as equation 4. Now the question may arise why we are replacing ADC by ACD or why we are replacing ADC by ACD and not the other way around. The reason is that we have to prove that BCD is a right angle. Now BCD is this particular angle, right? So this angle comprises of two more angles, that is ACB and ACD. So since in these two expressions we have the parts of these two angles, therefore we will try to bring the equations in terms of angle BCD. So angle ACB is a part of BCD. Therefore here instead of ABC we have written twice of ACB. ACB plus ACB becomes twice of ACB. Similarly here also in triangle ACD we have ADC, but angle ACD is a part of angle BCD, this angle. Therefore, we are rewriting angle ADC as ACD because we need this particular angle in the expression here. After marking them as equation 3 and 4, let us now add them. So if we add the left hand sides, we will get twice of ABC plus twice of ACB plus angle BAC is equal plus twice of ACD plus angle CAD is equal to, on the right hand side, 180 plus 180. These implies we'll take 2 common from these two expressions and we'll get twice of angle ACB plus twice of, we have taken common 2 plus angle ACD plus angle BAC plus CAD is equals to 360. Now, what we can see here is this is angle BAC and this is angle CAD. BA has been extended to D. That means angle BD or BD is a straight line. So, if BD is a straight line, then sum of these two angles will definitely be 180 because it is a linear pair of angles. Therefore, the sum of these two can be written as 180. Therefore, instead of angle BAC plus CAD, we will rewrite it as 180 degree. Now, angle ACB plus angle ACD. Now, these two angles, sum of these two equals to BCD. So, twice of BCD is equals plus 180 is equals to 360 degree. This implies that twice of BCD is equals to 360 degree minus 180, that is 180. Hence, we can write down angle BCD is equal to 90 degree. Hence, ABC is a right angled triangle in which angle A is 90 degree and AB is equal to AC. Find angle B and angle C. So, from here what we can see is that we have a right triangle ABC where angle A is 90 degree right over here. It also says that AB is equals to AC. So we have the side AB equal to AC. So we have constructed the diagram. Now we have to find out the value of B and angle C. So in the triangle we have AB equals to AC and by theorem we know their opposite angles are equal. So if AB equals to AC, their opposite angles, that is angle B or ABC, is equal to angle C, that is ACB. So angle ABC is equal to angle ACB by theorem. Now if we take the sum of all the three angles of the triangle using angle sum property, then angle A plus angle B plus angle C will be equals to 180. Now we already know it is given that angle A is 90 degree. So if we place the values, then we can say angle B plus angle C plus 90 degree equals to 180 degree. Now angle B plus angle C is equals to 90. We already know that angle B equals to C by this condition. So if we equate them, we'll get each of these equals to twice of angle B equals to 90 by 2, right? Twice of angle B equals to 90, therefore angle B is equals to 90 by 2, that is 45 degree. Angle C is also 45 degree. Hence the values of angle B and C are equal and both of them are 45 degree. Show that the angles of an equilateral triangle are 60 degree each. So for question number 8, let us draw a diagram. So we have a triangle ABC. Okay. So if the triangle is equilateral, they said it is an equilateral triangle. By equilateral triangle, we mean to say that all the sides of the triangle are equal in length. So we can clearly say that AB is equals to AC is equals to CA. All three sides are equal. So we have to prove that each of the angles are 60 degree. Now for an isosceles triangle, if two sides are equal, their opposite angles are also equal by theorem. So if AB equals to AC, we can say if AB equals to AC, their opposite angles, angle B equals to angle C. Similarly, if AC equals to BC, their opposite angles, angle A and angle B will also be equal. Let us mark them as equation 1 and 2. So from 1 and 2 we can clearly say that all the three angles are equal. Angle A equals to B equals to C. Let us mark them as X. Using the angle sum property, we can say the sum of all three angles equals to 180. So angle A plus angle B plus angle C is equals to 180. Let us put the value of each angle. Therefore, we can say that x plus x equals to 180 using this relation. So 3x equals to 180, x equals to 60. Hence, we can say all the three angles, that is angle A, angle B and angle C, are 60 degree. And hence, the angles of an equilateral triangle are 60 degree each. I hope the video was helpful to you. Thank you for watching it. Take care. Bye-bye.